Okay, this topic's going to look at maths for regular expressions, and what we're really going to refer to is what's called sets. Now a set is a collection of unordered values where each value will appear in the set just once. Here's an example of a set identified here. That set contains 5 members, 5 objects, 5 elements, whatever you wish to call them. And these are 1, 2, 3, 4 and 5. Any value can be represented in a set. For example, if we've got n equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, n represents natural numbers. Another example of a set below, we've got z. Z is integers, and you'll notice we've got the 3 dots that appear either side. This means that this continues. So for instance 0, 1, 2, 3 and so on. And minus 3, and that would be so on backwards. So that's how we represent a set. We have the squiggly brackets, we have the name of the set, we can give it a name, we can give it a letter, or we could use one of the symbols from our examples such as natural numbers, irrational numbers, integers, etc. Now we have what's called set comprehension, and that is a way that we can define the members and the properties of a set without actually having to write it all out. So here is an example of us building a set, and what we're saying is A is a set where X is such that X is a member of a natural number and X is greater than or equal to 1. So that is X is that such that X is a member of natural numbers and X is greater than or equal to 1. So that's how we read it. So A is the name of the set, the curly brackets represent the contents of the set, X represents the actual value of the set that will be defined, the pipe symbol such that, the euro style symbol, a member of, N is all of the natural numbers, the hat means and, greater than or equal to 1, and that's how we can define a set. We have a special thing known as an empty set. So this is where we just have the curly braces open closed. The empty set has no elements. However, don't be confused with 0. So 0 is a different value to an empty set. So think of a set as a container. Think of it as being null. It's got nothing inside it. We have finite and infinite sets as well. So a finite set is said to have cardinality. And cardinality means the size of it. So if there's 5 items in our set, it has a cardinality of 5. So cardinality means that we can count the number of elements inside it using our natural numbers. That can be referred to as a countable set. So a cardinality set is simply the number of elements. We have infinite sets, such as our set of Z, our integers. There can be an infinite number of integers. Now infinite sets, they don't have cardinality because we don't know the total size of it, and these become known as countably infinite sets. So we can count them, we can use natural numbers to count these, and we can go 1, 2, 3 and carry on going, and you can actually go up to n values, so they become countably infinite. There's something known as the Cartesian product. So this is a way that we can join 2 or more sets together. So imagine if we've got set A, which has the values A, B, C, set B has the values 1, 2, 3, and the Cartesian product of the 2 sets is taking each value and joining it. So we get A1, A2, A3, B1, B2, B3, C1, C2, C3, and there is our Cartesian product result of the 2 sets. Similarly, here is another example of Cartesian product. So this just has a little bit more of an explanation there, and it shows it in our set comprehension. And if set A is 1, 2, 3 and set B is 2, 4, 6, the Cartesian product, where we're set to multiply both together, gives us 1, 2, 1, 4, 1, 6, 2, 2, 2, 4, 2, 6, 3, 2, 3, 4, 3, 6. Now we can combine sets using a union, an intersection and a difference. Union joins together two sets, and it creates a new set with all the values that are contained in both sets. We have an intersection when the two sets are joined together, and it contains those elements that are common to both. So with union, you can imagine if one set we had 1, 2 and 3, and in another set we had 3, 4 and 5, the union would be 1, 2, 3, 4, 5. It would contain 5 elements. The intersection of them two sets would just be the number 3, because that would be common in both. And the difference are all the values that, when the sets are joined, are just in either a set but not in both, such as 1, 2, 4 and 5. We have subsets. So we can say if one element is within another, then it's said to be in a subset. So for example, 1, 3, 5, 7, 9 is a subset of B, 1, 2, 3, 4, 5 and all integers after that. And that can be shown with this symbol. So a subset is defined as a set that is wholly contained within another set. For example, you've got 0, 1, 2, 3 and you've got 1 and 2. Then B is a subset of A, and A is a superset of B. That symbol means a subset of. So B is a subset of A. Technically, a subset can have exactly the same elements in the superset. So if C has got 0, 1, 2, 3 and D has got 0, 1, 2, 3, then C is the same as D, but C is also a subset of D. Both are true. If we take away the line, we get proper subset. And that's defined as one where at least one element in the superset is not in the subset. So here's the superset, 0, 1, 2, 3, and there's our subset. And this is a proper subset of that. So in summary, that gives us an overview of the maths for regular expressions.